So our topic is electric field and electric field intensity. Okay, what is the meaning of the electric field? Electric field. The area surround surround the charge distribution where the influence of charge may be experienced the area surround the charge distribution where the influence of the charge may be experienced is defined as electric field. Okay, will be defined as electric field. Okay, the area surrounding by the charge distribution where the influence of charge may be experienced. Okay, that is will be defined the electric field. Okay, for example, if this is electric charge, for example, these are the electron distributed or a proton are distributed. The area around this where the influence of electric field may be experienced means if you take a test charge and then test experience on any port, that area will be defined as a electric field. Okay, got it? Okay, so okay, so this is electric field. What will be the electric field? Electric field intensity. What will be the electric field intensity? The strength of the, okay, this electric field, strength of the electric field is defined as a electric field. The strength is defined as electric field intensity. Okay, the power, okay, intensity, that will be defined as a electric field intensity, and it will be always equal to, and it will be always or force per unit charge is experienced by test charge or other charge is defined as electric field intensity. Okay, the force per unit charge will be defined as electric field intensity. Okay, yes, the meaning is the same. Okay? The difference is only the way to explain. Okay, the strength is also that the force per unit. Okay, the meaning is same. That is this one definition. Actually, that are one, but the way of explanation is the different. Okay, mode of explanation is different. Okay, so electric field will be what will be the electric field? That will be equal to force per unit charge. Okay, that if you say that that is the Q naught, okay, that will be defined as electric field intensity. Okay, and the unit, what will be the unit? Unit will be Newton per coulomb. Okay. Okay, Newton per coulomb. Okay, why I'm using the knot? That is a good question. Actually, we usually use knot or I or any. That is actually here is it is representing the fixed value. I will explain because actually you have missed the lecture. Here is the distribution of charge that vary with point to point. If there is these are the charge, number of charges, if there is a charges, and there is any point, there is any charge Qi, okay, and then if we are interested to find the force, okay, we know that if these are the number of charges, okay, we know that what is the force according to Coulomb law? What is the force? Force on ith charge, j charge due to ith charge, k q qj, sum was I, okay, I not equal to j. I have told that if j will be not included, okay, to n. If this ith charge is inside this distributed charges, then I will be not included. Okay, that will be j will be outside. For example, I is third charge. Excuse me. If I is the third charge, then Q1, Q2, Q4, Q5, third charge will be excluded. If I is if j is the 5 charge, if you are measuring the force on, sorry, this is j. If j is the 4th charge, then 4th will be missing and remaining of 1 to n will be included. Okay, so that will be I have already stated that will be j I square and j I unit vector. Yes, only that. Okay, k q j j I square r square. These are the same distance, but okay, this is j. Okay, and what is the electric field intensity? Electric field intensity will be force due to the force at the point of on the test charge. Okay, if Qj is test charge, okay, mean on which you are on which you are interested to find the electric field intensity, force per unit charge is defined as electric field intensity. Okay, and for discrete charge distribution, that will be k q j not equal to I n q I r j I square r j I, okay, unit vector, and divided by qj. This is qj is maybe any charge, maybe a test charge. It is not necessary that is only the test charge. There may be any charge. Okay, Okay, and but this will be cancelled out with this. Okay, so that means the E will be, electric field intensity will be J not equal to I N Q I over R J I square R J I unit vector. No, there are n number of charges. You may say that these are the test charges, these are the distributed charges, 1, 2, 3, 4, up till n. Okay, so these J is different from the I to J. J mean this is J mean, if you say that this is test charge, you may say that this is test charge, then you say that this J is 0 and J, if that is you may also define, for example, 1 minute please, J, sorry, that was I not equal to J, yes? I may write in this way, if J is test charge, okay, then we may write that that will be a Q naught J equal to I equal to 1 to n, then we don't need to write the condition. Okay, if I say that whatever this charge, if I represent this charge with the I, then I to n will be a distributed charge, and that will be a Q I, okay, and divided by R I0. This R means the charge I. There are different charges. Okay, this for example, this is I0, this is I2, this is RI3. I mean, there are many different charge distribution. Okay, and this is IN. Okay, they are different. I value is changing. These are the distributed charge. Okay, and this is the charge on which we are finding the electric force. That may be a test charge, there may be any other charge. That is not necessary, that will be only the test charge, there may be a other charge, okay. And divided by test charge, to be test charge is not necessary, okay. The summation on this, because the summation is on that, that's why that not come out from because the summation is on I, okay. So that may not come from can't be come out from the sign of summation. But Q naught, there is no summation on Q naught, so they maybe come out from. Okay. So this is the force. This can because summation नहीं है इस वजह से, ठीक है, ये सबसे multiply हो रहा है, so that's why maybe cancel out. Okay. So this will be this, and you may write E as a K I equal to 1 to N Q I over R I0 R I0 unit vector. Okay, so that will be this. Yes. Okay. There is okay. This was a for a discrete charge distribution. This relation was for this was a for discrete charge distribution. So this relationship are discrete charge distribution. Okay, there are 1, 2, 3, 4. There are many different charges that are distributed. Yes. Okay. The no problem is that this charge, whatever that is the test charge, or this is any charge. Okay, they may be a test charge, they may be any other charge. Okay, this is a cancel out. So now from this expression we may say that electric field intensity is not this is a vector quantity. So because if we are considering the vectors, okay. Since the test charge are the force on which we are applying the force, we are finding the force due to that charge force. Because this test charge, we don't need test charge. Okay, so that means Q naught is cancelled with cancel out with. So the importance of test charge is ended. So we don't need any test charge. Actually, the electric field intensity is not depending upon the test charge or any other on test charge, but depending upon the distance. because that is the depending. So electric field intensity vary with the change in position, not vary with the source charge, distribution of the charge, but will not vary with the test charge, but depend upon the distance from the distribution of the charge. जितना ज़्यादा distribution of charge से यानी difference होगा, जितना ज़्यादा फासला होगा, उतना उसका effect different होगा, कम होगा, ठीक है? So that means the electric field intensity depend upon the distance from the distribution of the charge. Okay. Okay. There are three types. We have already for continuous charge distribution, for continuous charge distribution. For continuous charge distribution, as I have already explained, for in Coulomb law. In Coulomb law, I have already explained. The electric field will be K. The summation will be for continuous summation will be up to infinity, and that become a continuous, and so that will become 0 to Q continuous charge distribution. dq I have already explained in a Coulomb law how this will be equal to this. Okay, and r is distance from r square r unit vector. So this here r is distance of point from source charge. Okay. So this r is distance. This is the source charge, or this is point. Distance of point P. Okay. If I say that this is a point P, now this the part role of the test charge is ended. Okay. So there is no importance of the test charge. Now the importance is the point P. R is not the distance of test charge from the source charge. R is the distance of a point P. Distance of the point. Distance of a point P from source charge. Okay, so there are different distribution of, so that will be, okay, from continuous charge distribution. Because this distribution is continuous, so I can replace with this continuous charge distribution. Okay, so this will be equal to this. Okay, okay. Now this is the result. Okay, and in the these are the vectors. Okay, so E will be equal to K 0 to Q dq r cube. They may be written in the form of this. Okay, I have multiplied and divided with the magnitude. Okay. That's mark. Okay, for मैग्नीट्यूड से मल्टीप्लाई भी किया, ठीक है, और डिवाइड भी कर दिया, तो ये आर वेक्टर बन गया। यार मैंने मैग्नीट्यूड से आर स्क्वायर ही यस okay 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 this okay for continuous charge distribution for continuous sorry okay for linear charge distribution for linear charge distribution dq is equal to mu alpha d alpha. Okay, mu is I have already explained in the Coulomb law. Oh, what is the meaning of mu is the linear charge distribution. I have already explained in the Coulomb law. Okay, and when so this will be linear charge distribution. mean if charge is distributed linearly, okay, along the line, mean the along the wire, okay.
For continuous surface charge.
नहीं, point from the continuous charges. नहीं, no. Yeah, this is for continuous. 1 minute. This is the for linear charges. No, that is not for surface. That is the continuous charge. This expression is for continuous. अच्छा, नहीं, मैं बताता हूँ बात में. अभी ये नोट करो. For continuous charge distribution ये और ये आ गया. सरफेस के लिए आ गया था, ठीक है. So this will be dq, and that is mu alpha d alpha, and this alpha is different than this r. This is r is distance. This is the distribution. This is the parameter along the distribution. This alpha is different than this r. This is also a distance, but this is a distance of the. I mean, this is varying along the. No. This is varying from the. This is alpha total. This is varying along the length charge distribution. Okay. Alpha is varying along the length, not only small. D alpha means small. Alpha means parameter of charge distribution along line. Okay. For surface charge distribution, what will be the surface charge distribution? That was a surface. You are mixing something. Okay. So for surface charge distribution, if this is a surface mean plane. Okay. That has a two. Surface mean plane. Yes, Mariam. Surface means plane. Okay. Mean if this is a thin plate, if it has not a width. Okay. It's only plate surface. These surfaces are defined as the plane. Okay. If you consider the then that will be have a two pair. That will have d alpha, d beta. So this surface distribution will have a two parameters. Okay. So this so dq will be sigma. Sigma will be function of alpha beta, d alpha, d beta, because it will be. So all surfaces are a plane or a two dimension. Okay, and they have width and length, but no thickness. Okay, and they will be. So this will be a surface charge distribution, and dq will be equal to this. And I have already explained in a column law why this is equal to this. Okay, so for this you have to visit the lecture on a column law. Okay, and so this electric force will become K alpha naught linear charge distribution. Okay, I have not write the. Okay, this is for linear charge distribution. For surface charge distribution, okay, that will be a two-dimensional parameter. Okay. No, that first was the linear charge distribution. Linear mean along the line. This is the surface. Yani if the charge is distribution like a capacitor plate, plain capacitor plate. Okay, if charge is distributed on a, as you know, this plate. If this is a plate and charge, parallel plate capacitor आपने पढ़ा होगा, ठीक है, उसमें charge जो है ये हम पढ़ेंगे. No, वो आगे है. हाँ, कंटिन्यूस तो है ही है ना, कंटिन्यूस के ही पढ़ रहे हैं ना, लीनियर चार्ज डिस्ट्रीब्यूशन सरफेस कंटिन्यूस surface charge distribution. Okay, now okay. And for volume charge distribution, what will be the for continuous volume charge distribution? Alpha naught to alpha. Alpha naught to alpha. Alpha naught to alpha. Yes. For continuous volume charge distribution.
So ये epsilon हो ना ये second year.
ये क्या?
Epsilon हो या second year alpha bigger than
नहीं सिग्मा. This is sigma. Sigma.
तो इसका वो सम भी होता है.
नहीं, this is not sum. This is sigma. This is surface charge per unit surface. Sorry, ठीक है. जैसे चार्ज पर यूनिट वॉल्यूम है ना, इसी तरह ये रेशियो है. ठीक है. For continuous volume, that is everything is discussed in the Coulomb law. Okay, ठीक है. और वॉल्यूम अगर आपने वो देखा होता तो आपको क्लियर होता. Volume for volume charge distribution, this is looking like a plane, but actually this is a 3-dimension. Okay, like if I consider that if I consider small patch. Okay, these has a 3-dimensional form, that is d alpha, d beta, d gamma. Okay, so these have the 3 x-axis, y-axis, and z-axis. These have a thickness as well as a volume as well as a length. Okay, so for this dq will be volume charge distribution. As you know that in metric and FSC, you usually in metric FSC you studied the volume charge distribution. That is the charge per unit volume. Yes, and that is usually represented by the rho, and that will be alpha, beta, function of gamma, and that will be a d alpha. This will be equal to this. dq will be d alpha, d beta, and d gamma. Okay, so that will be equal to this, and so what will be, this is also a vector quantity, so E vector will be equal to K alpha naught to alpha, beta naught to beta.
ये जो तीन mention of the diagram नहीं है. फिर पता चला कि d alpha कितने पार्ट में की.
आप ठीक है, डी अल्फा, डी बीटा, डी गैमा. ठीक है. ओके, असल ये सॉरी गैमा नॉट टू गैमा. ठीक है. नाउ सही है.